Welcome. My name is Baruch. I'm developer advocate with JFrog. When we do a lot of Groovy. And that's the reason I'm here speaking to you about Groovy. One of the most amazing parts for me in Groovy is the magic. I love the magic. It's probably some kind of something that I have from my childhood. Groovy is magical in so many ways. I'm going to show you now today one of the most fascinating things in Groovy, and then the ability for you to create this magic. So what we are going to do today, we are going to grow methods in the place where they do not exist. And we are going to do it in at least, I think, 5 or 6 different ways. We are going to write crazy Java code. We are going to simplify it to sane Java code. And then we are going to simplify it even more sane Groovy code. And then we are going all the way back to Java, to the insane code, with compiler emitting your own messages and what's not. It should be a funny talk. I'll try to keep it that way. Okay, so I'll start with to see where are we standing. Who attended Dr. Paul King's yesterday's talk about AST Transformations? Okay, a couple of hands. Okay, who attended any talk about AST Transformations in their lives? Okay, couple of talks. Yeah, so I asked because I really hoped I will see more hands and I will be able to skip this theoretical part that I really don't know. Okay, no, just kidding. Yeah, so I'll try to keep it short because I don't know. Okay, I'll try to keep it short. So let's start with the reason why the AST transformations were invented, and I'll start by doing something very, very simple. I'll go to my Groovy main, and I'm going to create a person class. Yeah, the dummy, you know why. Person class, and in my person class, I'm going to add 2 properties, string first name and string last name. That's a Groovy, plain old Groovy object, and with 2 properties. Now I'm going to compile this class, and I'm going to show you the generated bytecode. No, I'm not going to show you the bytecode. I'm not that good. Yeah. Those are my first 48 hours on Mac ever. So my muscle memory suffers, shouts on me, and I need to stop my fingers to go to the keys I used to, so I'm sorry for being a little bit rusty. Show in Finder. Do I have this show in Finder stuff? No? At the bottom, that's to bottom, right? Yeah, reveal in Finder. This is what I'm looking. Okay, so yeah, I won't find it that way. Right? Will I? Yeah, I told you it's painful. Ah, so it's below the git style. Okay, that makes sense. How can I? Yeah. It's supposed to be below. Yeah, below. That's nice that it's below. Maybe it's that. Let's try. I clicked something. No, it didn't. Yeah. So, but let's try to find it in Finder. It should be here. Projects. AST talk. Yeah, it was easy. Build classes. Main person. Yeah, it was easy. Yeah. Okay. Yeah. So now look what happened. I hope I won't surprise anyone by showing you that the person class now have getters and setters. Is there anyone here who didn't know that? Yeah, you're ashamed. Who didn't know that? That's okay. That's okay. Yeah, I'll assume that there's 1 or 2. I will let you go with that. Now, this is very cool because this stuff reduces boilerplate, isn't it? Reducing boilerplate is good. We love reducing. This is what a lot of Groovy is about, right? Less code, more readable code, etc., etc. Now, there is a guy that I didn't see for a long time in any Groovy conference, what's the name? Forget the name, shame on me. No, the Danoferin. Danoferin, who invented actually the AST transformations. And his thought was, okay, this is very cool, but this is not the only boilerplate I have. I actually have more boilerplate in different places. And he thought it when he looked at the Java bindable properties. You know what Java bindable properties are? The ability to add listeners on getters and setters inside Java object. Whoever saw the code of Java bindable property? Okay, that's good for you. Now imagine this code adding listener support on getters and setters. That's like horrible. And all that can be actually eliminated in the same way we eliminated getters and setters. So imagine an annotation that you put on the property, and it's bindable. Bytecode will have all this nightmare. So the thing is, you actually have more boilerplate to reduce, and this boilerplate is different for each and every one of us. So I never used bindable property because I never wrote a proper desktop application when you actually need a bindable property. That's Danoferin's pain. But I used WebSphere with EGB2. That will stay with me till the day I die. I will never forget it. And when I think about the amounts of boilerplate we have there, that's insane, that's incredible. And having something like that move the whole boilerplate from source to the bytecode, to the generated bytecode, would be awesome. We don't need it anymore, and that's a good thing, but I still can imagine. Okay, so that's what the AST transformations are about. This is the ability to reduce boilerplate and generate bytecode in the places when you need them, in the way that you need them. And this is what we are going to learn today, is how to do it. So the most important concept in writing AST transformations, there are two, the AST and the transformations. So we're going to talk about AST now. AST stands for Abstract Syntax Tree. Now, there is a whole theory. We have some doctors over here who actually know this theory. What I know is this is kind of a tree that represents bytecode. The closest thing that I can think of, and it's like very, very simplified comparing to the real AST tree, is the reflection API. Okay, I can look at the class, and I can see the name of the class, the superclass, etc., the list of the methods, the list of the fields, right? On each and every method or field, I can see the modifiers. I can see whether it's static or not. For methods, the return type, the exception throws, etc., etc. So this is kind of very simplified concept, the same concept, the runtime concept for AST transformations. Now, AST transformations are much more complete because they not only represent the objects and their content, but they represent the whole syntax tree of your source. It includes statements, it includes expressions, it includes each and every local variable that you have, and all the code is represented as a tree. Now, how can you look at this tree? How can you learn about this tree? There are some tools, and the simplest tool that every one of you have is the Groovy Console. So I'm going to show you the AST browser in the Groovy Console. Let's open, that's not the correct window. Groovy Console, yeah. Here we go. Yeah, this is the Groovy Console, and I will do here something like 1 + 1 = 2. And it's way too small. Larger font, it's Shift-Command-L. Yeah. Okay, now, I would say that this is rather a simple piece of code. And now let's look at the tree of this simple code. What we need to go is inspect AST. Now what we have here is, where is my AST tree? Ah, okay, I have, yeah, double equals helps. Yeah, I'm still in the puzzlers, you see. I'm still in the puzzlers. I'm still in the puzzlers, okay. View, I thought parentheses could help, right? Yeah. Yeah, and I have a tree. Hope so. Yeah, that's very true as well. Okay, so I have a bunch of stuff, and what I actually mean, what I need is the run methods, which were generated from my script, and here is the block statement, and oh yeah, I told you. Yeah, all the parentheses here, it's to make it work. Yep. Otherwise it won't work without parentheses. Yeah. Okay, so all this crazy stuff. Okay, so basically the run method were added on top of the script to make it work. That's okay. And from here all the way down, all this craziness, it's a tree that represents this very basic expression of 1 + 1 equals 2. So let's try to understand, and let's look at it too. So here we have a block statement, because this is inside method, so this is the code of block. It is return. Return was added automatically because this is the only expression in my script, so it should be returned. It's still not relevant. We are starting here. So here our binary expression. It's binary because we have equals. Okay? We have operator and two operands. It consists of a constant, 2, and another binary expression, which again have operator plus and two operands 1 and 1. And those are the two constants, 1 and 1. Okay, so all that, starting from here, is my AST tree for this expression. So if I need to modify, to transform AST transformations, those are the terms that I'm going to operate on. I'm going to do stuff with binary expressions and constant expressions, etc., etc. So those are my tools. Now, what it mainly does, it produces like a whole bunch of non-very readable code. The good thing about it, we're going to make it less code and more readable, and even better thing about it, that no one knows, because this goes inside your framework, your tool that you produce to your users, and your users don't even know about that. Now, if someone happens to look at your source, they will be very impressed with what they see, because this looks like very smart and impressive stuff. All right, so that was the theory. It wasn't much, but we will try to get practical as fast as possible. So all the examples here, not all the examples, most of the examples here are shamelessly taken from the great Groovy in Action book, 2nd edition. I think half of the authors of this book are sitting here, so I'm a little bit ashamed that I just stole their examples, but I hope they will forgive me. And the first, we are going to add.
We stole examples in our talks, and we didn't ask permission.
But you stole examples from your own book. I don't think it's count as a steal. What we are going to do now is adding the author field. So the idea is, we are going to add a field to each and every method, static field named author. So we have 2 types of transformations. We actually have more than 2 types of transformations: the global transformation, the local transformation, and the one new that I'm going to show you later. Global transformation works for everything. It means that every class, AST of every class, during the compilation process will be altered based on the rules that we add. Local transformations are local. They are only applied in some places when we want them applied. And those are most of the transformations that you know about. So when we're talking about toString or canonical or immutable or any of those like classical transformations, they are all local because they are all applied when you add an annotation and ask for it. Global transformations always work. Because of their global nature, they are much less useful because, you know, there are not many cases when you want to change everything for everybody, right? But we'll start with that just to show you how it works. So let's talk a little bit about testing transformations. Now, the thing is, it's kind of, there is a toilet flying outside the window. Sorry. I had to notice.
That will be in the video forever.
That is a fact.
Let's see if it's a shitty talk.
Okay, we'll do a test. If the toilet breaks into the room, it means it's a shitty talk. How about that? When it stays outside, it's like, we are testing you, dude. If it stays outside, I'm good. All right, yeah, testing AST transformations. There is a little bit of chicken and the egg here, because our tests of transformations should run after our transformations applied. But the source of our code are our transformations, so how can they be applied if they're not compiled yet? Okay, you understand this part? So we don't have much problem when we use a build tool, modern build tool, Gradle, or let's even say Maven. We'll give it to that. Because they have two phases, separate phases, of compiling the main part and compiling the tests. And we are good because our transformation source is on the main part, it's get compiled, and then when we come to sources, the transformations are already compiled and ready to be applied. That's not the case in the IDE. When I work with IntelliJ, the test class path, the test classes, and the main classes are compiled together, which means that I cannot apply the transformations because they are being compiled at the moment. So I cannot work with them. There are ways around it, and the simplest way around it, which is especially suitable for our talk, is just using the capability of Groovy to evaluate scripts on runtime. So what I'm going to do here, I'm going to write a test. It will be a Groovy test. It will be a Groovy class. That will be the name. Where is my test? Here is my test class. Okay? So let's make it full screen. Yeah. So what I'm going to do, I'm going to use assert script method of the Groovy test case to assert, to evaluate and assert a script during the test. That will solve the problem of chicken and the egg because everything will be compiled, my transformations will be compiled, and the script that I'm testing will be compiled during the test, which is after the transformations already compiled, so I'm good. Now, I hate extending test case that bring me memories. You already know my trauma, WebSphere, and EGB2, JUnit 3. So no, I won't extend any test cases. Okay, and now let's write a test. Message author edit. No? Ah, okay, yeah. So a void, it will be test, of course. A void, every class should have author field. Yep, that was what we're going to test. Here, Author test author edit. Here we go. Okay. Now we're going to do this trick of inject Groovy language. Yeah, perfect. So here is my test. You know, test first, test-driven development. Yeah? Very cool. This is my test. I'm writing a class which don't have any fields at all, and then I expect the author field to appear. Right? This is a very bold statement, and guess what? This test is going to fail miserably. At least I hope so. No, it shouldn't pass. Good. Missing property exception, no such property author for class. Okay? Which is the good thing. So now we are going to run our AST transformation, and I have this name to copy paste. And we are going to put it inside source main Java. Now let's talk for a second about writing transformations in Java or writing transformations in Groovy. We can write any class in our Groovy project in Java. We usually don't want to do it because of the obvious reasons. Transformations might be different. You might consider writing transformations and maintaining transformations in Java for the sake of performance. Now you can say, but Frederic is here in the room, so compile static, why not? And that's because transformations are not liable for transformations because they're transformations themselves. So you actually cannot apply compile static on your code in AST transformations, which means you can, but only on part of them, right? Not on all of them. It runs before?
The only problem in writing an AST transform in Groovy
yep.
is that you are spawning the dynamic runtime of Groovy during compilation, which really slows down everything. If you put compile static, it's okay.
And you can put compile static. Well, yeah, that's I didn't know. So it's a shame that Frederic is here. He spoiled on my point over here. Yeah, okay. So yeah. So let's pretend it's here and I'm right. No, just kidding. So yes, you might consider writing your AST transformations in Java for the sake of performance. So we will start with that. We will start with writing them with Java, and that means, you know, semicolons and all the joy. So here I have one. Author header class. Yeah. Okay. Full screen. Yeah. Okay, so let's look what we need in order to write an AST transformation. We need a class. This class needs to extend from abstract AST transformation. And it should have an annotation of Groovy AST transformation with a phase. Now, what that phase means is when this transformation should be applied. So we have 7 phases here in the compile phase. Enum, initialization, parsing, convention, semantic analysis, canonicalization, instruction selection, etc., etc. Now, in his talk yesterday, Paul explained relatively deeply what those phases are and what job each and every one of them perform, on which phase every transformation should go. I will just say, you see those 3? Conversion, semantic analysis, canonicalization. Those are the 3 for you. You don't care about the rest. Just do it here, here, or here. Because here is too early, here is too late, period. Again, this is not very right? You can do it before and you can do it after. But that's the safe place to be. Just pick one of them and you're good. This is what I'm going to do. I'm going to write any of the 3 examples of transformations, each and every of them in another phase, just for fun of it. This will go to the conversion phase. Okay, and now we have a visit. We have a visit method that we inherit from our abstract AST transformation. It is abstract there, so we have to implement it here. The name visit implies that it's a part of the visitor design pattern, which is true. This is how the AST tree is traversed during the compilation. And who knows the visitor pattern? OK, I will ask, who knows about the visitor pattern? Who knows visitor pattern? Yeah, OK. Good thing you don't care. You just have this visit method, you implement it, that's good. So now, what do we have here? We have two elements. One of them is nodes, and the other is source. Now, again, the simple way to think about them, source is the whole source code. Node is something that was hit when you asked for a transformation. Now, when we're talking about global transformation, we care about the source as a whole. So all we need is all the source code. And here, we're going to use it in author, editor, iter. OK, so here we have an iteration, Java 8. So we use the for each method of the list of classes. We take all the classes from our AST. All I care about classes. And then I go for each and every one of them. That's a global transformation. I want to add my author field to each and every class. OK. And here we go. Whoa, that wasn't formatted very well. And it didn't help. That always helps. Yeah. OK. So for each node, which actually means each class, I add a field. It will be called author. It will have public static final modifiers. It will be of type string, and it will contain constant expression JBaruch. All right? That's all it takes to add static field to all the classes. So now I will try to run my test again. Guess what? It still fails. And that's because, OK, now I have some class. It even implements the transformation superclass. It even has the annotation. But it's still not enough. You need to register your transformation with Groovy. And that is done in very old-fashioned way of adding a property file. It's actually not a real property, but some kind of a text file inside meta-inf services. That's the name of the file that should be there. What Groovy does, it asks for all the resources with that name, got a bunch of files with the same name. All those files are registered AST transformations. We're going to add our own there. So it's in meta-inf services. I'm going to create a file here, and that will be the name. And inside, we will put a fully qualified name of our class, other AST transformation. Now there is some, the third try, I hit the correct key combination. Run it again, and here's magic. Now we have the author field on every class, and we just created that magic. I do this talk, I think, for the fourth time, and I'm still excited to seeing the magic happens. I really love it. Yeah, so that was nice. Yeah. OK. That was one global transformation written in Java. You didn't get scared by the AST code just yet. Here we go. The next one will be adding the message method. This time, we will write a local transformation, which means that it will be applied only by some marker when I will ask for it. And this marker is usually an annotation. There are some cases where it's not, but usually it is a notation. Like toString, immutable, canonical, the guys that we know. So this is what we are going to do. So we will start with messenger annotation. Again, it can be Java, it can be Groovy. Let's continue with Java. It will be here, it will be messenger, and it will be annotation. So now this guy is a normal Java annotation. So it has a retention. What will be the retention of this annotation? Source, of course. It will be source because we really don't need this annotation in runtime. We only need it in the compile time. So source is perfect for me. And we will apply this annotation on the class. So the target will be a type. We will apply it on the type on the class, and then this is what we want to do. Each class that has a message annotation, a messenger annotation, will grow a message method that we will be able to call. Okay? So we annotate the class with messenger, and boom, we have message method. Now let's do a nice trick. I promised you a hell of AST, so we need to complicate things a bit. What we are going to have here is a property of the annotation that will allow us to select whether we want the println to be caps or not. It will naturally be Boolean type, called, guess what, right? And we don't want it to be on by default. Now, does anybody have any clue why the hell this is a method? I don't know why, but okay, this is how it works. This is how annotations work. Yeah, that's excuse for many things, but not particularly this thing. It's because this is the interface, but it's not really the interface. So, I don't know. Never mind. Okay, so this is our messenger shout, and now we can run a test. We can write a test for this. For this case, so we have test void class as annotated with messenger should have message. Right? That's my test, and here I'm going to do the messenger. Where is my test class? Yeah, here. Okay, that's a lot of test. Full screen, yep, it worked. Let's see if, yeah. All right, not that. That, thank you very much. Groovy, yay, okay. Okay, so here I have some code that captures the system out. So the println I could assert on it. Not interesting in particular. And here we go. Quite full messenger annotation on it. Shout false. And then I would like to have the message method. Okay? Then I can compare it and check that it's all right. Reset the control output, and then the loud foo, which has the messenger with shout true, and I expect it to be caps. Okay, this is what I want to happen, and just to verify that we are good and I'm not trying to trick you, I will run this test to verify that it actually falls. It falls because missing method exception. No signature of method message is applicable to string, which means that I didn't trick you so far. Doesn't matter that you can trust me, but so far the toilet is on the outside and the tests are failing. Okay, what we need is message header AST transformation class. So we are still in Java, and I'm going to edit here. Yep, here. All right. Yeah, so this is exactly the same code, not that. That is exactly the same code you showed earlier. Let's collapse the import. Can I? I don't see the pluses here in the full screen. Never mind. OK, so here I have exactly the same code, extending up, I have the annotation, just randomly selected another face of the 3 that I allowed you to use. And here is our visit method. And here, what I'm interested in, it's not the source anymore, but the nodes. Those nodes is the array of interesting stuff. Now, how do you know what's in there? I'm telling you, and then you go and read the Marvel's book, and then you know that you're usually interested in 2 first elements of this nodes array. So here, we're going to have the messenger, header, what do I need? Variables, I think. Is it? No, sorry about that. Oh, yeah, this one, sorry. Yeah, this is good. So here, I'm going to use, as I mentioned, the first 2 nodes. Nodes at place 0 is the annotation that triggered this transformation. In our case, this is the getter annotation. If you have a marker annotation, and we'll see this example in a minute, you actually don't care about it. You just know that you were hit by this annotation, and that's good. In our case, we do care about it because we have this shout property in it. So I will need this annotation. And here I go, and from this annotation, I get the member that named shout, and it will be a constant expression for me. Note that number not at the index 1 is the annotated thing, the annotated node. In our example, this is annotated class, because the target of this annotation was type. If I have annotation that can be put both on class and or methods, for example, then I can get different things here. And I actually need to check on which element the annotation was hit. But in our example, it is always on class. So I can just say that's fine. And here I have a message variables. OK. So now I will do some preparation work. What I'm doing here is I prepare a new variable expression that's called message. Message will be the name of the method and the parameter that this message will get.
So every class needs to have this annotation, or let's say some class doesn't have visit?
No, this is a local transformation. I put my messenger annotation only on the class that I want this magic to happen. So here in our test, in order for this stuff to work, I had to annotate every class that I expect message to appear. So I annotated this, and I annotated this. And actually, good test would be adding another class without annotation and verifying that it doesn't have the message method, right? Just to check that I accidentally didn't write a global transformation when I actually meant to write a local one. That probably wouldn't happen. It's not that easy to be confused. But yeah, that's OK. OK, so yeah, I prepared a variable expression. This variable expression will actually be the parameter, the argument that I'm going to read from the call of the message in order to appear in my code. And now I need to prepare something else, and that's toUpperCase call. I will have to call toUpperCase on string if the shout is set to true. So let's prepare it in advice. What I'm doing here is preparing a method call expression that will work on the object message. This is the object I'm going to get from the argument of the method. And then I'm going to call the method to uppercase. This is string, so it will work. And to uppercase don't have any arguments. Okay? So this will be part of my code. Now let's go forward with it. Message header code. The next step will be to construct the actual code of my new generated message. So my code will consist of the following. I'm going to call a method on this. It will be the Println method. Just for context, whoever not sure how the Println works in Groovy, it looks like a global function, but it's actually not. It comes from object. So every object has the toString method, the Println method. When you type Println something, it's actually called this. So this is what we do here. We call Println on this. And then we construct the expression with the question mark, with the 3 operators. First must be a Boolean. We ask whether the shout is true or false. The second operand is what to do if the shout is true. And that will be call to uppercase. I wanted to prepare it earlier. The third will be what to do when it's false, and that will be just send the message as it is. Right? So what is written here is actually something like that. So we have this message foo, right? And then let's make it a little bit bigger. Will it work? Not so much. Maybe now, not so much. Maybe that. Yeah, okay, that works. Yeah, it's okay. I'm getting there. And then we have this shout. So that was string. And now we have shout, which is whatever, true or false. And then we have our code, which is Println shout, yes or no. If yes, message to uppercase. Otherwise, message. This, what we try to generate, this will be the content of the generated message. When the shout will come from the annotation, and the message will come from the attribute of the message itself. Okay? So this is what we have here. And now, this is the content of our method. So the last thing is adding, where is my, okay. The last will be adding the method as well, itself. So here we go. Whoop. I forgot the declared class. No, it's the annotated class. Oh, yeah, I forgot some piece here on the main. Oh, that's the main. Thank you. Yeah. Yeah, message code method, this one. No, I just have the wrong snippet. Yeah, okay. So what we will have here is actually a annotated class, add method, and then a, right, that's add method. Yeah, yeah, the name will be a message, and the modifiers will be a, that's, yeah, that one, public or a, no, it's just public. Yeah, yeah, it's just public. Yeah, and then what's next? I hate this Mac at the moment, sorry. I'll get used to it. Return type a void. I have it on the class node. A class node void. You know what? I'll just use the other snippet and I'll fix it. What did I do? I did something wrong. No, I just closed the project, I think, no? No, I'm okay. Yeah, okay. So what I wanted to do is to delete this guy and instead trying to do this message header method and change it to be annotated class, to be message, to be public only, empty array params. Wow, this is complicated. Parameters.empty array, that's simple? Yeah, I need the message. So I just need a string. Parameter. Yeah, it's the array. Oh! Sorry, guys, I'm in pain. Yeah, new parameter array, and here I have a new parameter or parameter type. No, I have this special. I don't remember. Okay, I know what I'm going to do. I'm going to cheat. Sorry, guys. I'm going to revert to whatever you will have. This is not. Okay. I suck. Yeah, this.
Take that string type line and then do a.
Yeah, this is the other point of. Okay. Yeah, sorry about that.
Inline the two. Just take the whole line.
Yeah, so that will be the next trick. I will show you later. Yeah, so shame on me. Yeah, well, actually, the toilet is closer than to the window now. But yeah, just to make sure that the test works. Yeah, so let's try the test, and let's see if it works now. And yeah. Well, still didn't work. Well, it still didn't work because I already mentioned in the previous time, the AST transformation is not registered. Now this time, because it's local transformation, it will be registered in a different way. What I need to do now is to tell that this special annotation, this message annotation that I added, is actually a special one. It's the annotation that has the AST transformation bind to it. So what I need to do is go into my messenger annotation and add here a new meta annotation on it, AST something something, Groovy AST transformation class, which has the class parameter and it accepts the AST transformation class. So it will be messenger header AST transformation. This is Java, so it will be with class. And now it should be much better. Yay! And it passed. Okay, so here we have local annotation annotated with messenger. Where is my cheat sheet? Okay, yeah, so achievement that loves too much hell of the AST. So hell I didn't manage to actually write it. But yeah, it was, that's the complicated stuff. This is what I, without proper copy pasting from some good source or having at least the Java doc of the whole tree, it's kind of complicated to get all these parameter statement expression AST nodes right. Yeah, so we got me there. And what you saw there was actually this part when we make it easier by using general utils. We are going to get here very, very soon. Now let's write another local AST transformation, which actually be simpler, and I want to show you something that is quite important. So again, let's start with the test, and here let's start with the simple one. It will be a void classes with main should have public static void main. What we are going to do now is have another annotation, another Java annotation, and this annotation will be main. The main annotation is going to add public static void main method. This method is going to run whatever is written in the method annotated with main annotation. Okay? So it will construct the object and then will run the code. And you will see it in example in a minute in the test. So the retention will still be source. And the target this time will be method. This is a marker annotation. I don't need to put anything in it. And let's go back and write the test. So here we have our test, and it will be main test address. A full screen, inject Groovy. Here we go. OK, so this is the code of stealing the system out again. Class foo, method greet, print hello world, annotated with main. What I expect class foo to have is a static method main, which accepts array of arguments of strings. This is the main method. And when I run it, I expect the greet method to run on the newly created foo object. All right? This is what we are going to try to do now and suck a little bit less than in the previous example. At least that's the plan. So what we need is main header AST transformation. That will be the class. And guess what? We are still in Java. It will be Java class again. All right. So here we still have the exact same idea. This time it will be canonicalization, just for the fun of saying canonicalization without making mistakes in it. Class implements everything as we saw, visit method, and again, we are interested in nodes because this is a local transformation, right? So we care about nodes. More so, we don't care about node at the 0 position now because we don't care about the annotation. There is nothing interested in it. We know that it's on method. It doesn't have any parameters. We don't care. So nodes number 1 this time will be a method node. This time it will occur in method. Okay? And we can get the class to each we need to add the main method from the method itself. So method node get declaring class will give me the class that we actually look for. Here, let's see if that is good now. Yeah. OK, so here is the empty array params. Now here, I will do some preparations again. I will need empty string array params, because this is what our newly generated methods, the params will be. And I will need a constructor call. I will need a constructor call because I will need to create a new object of this foo class. So here is the new constructor expression, and I'm calling the default constructor without parameters. This will be the code of my method. The code of my methods this time will be relatively simple. So my method will be call a method on the result of the constructor, which will be newly created foo object or whatever, which method to call, the method that was annotated with the annotation main, and pass it no arguments because this is our contract. If you want this message to be called, you don't pass any arguments in it. Of course, it can be complicated. For example, pass the arguments from the main method into this method. But let's keep it simple. And now I'm worried because if I know where to take it from the previous one, if that won't work, right? Here we go, we add method. Yeah, this works. So here is declaring class. I took it from the method. Add main method, public static void. Nope, the parameters are empty array of strings and and give it the code. Okay? That's and here is the empty array for exceptions. We don't throw any exceptions. And give it the code. That's the annotation. Now we know that we need to register it inside our annotation.
Can you use that empty array there?
Oh yeah, I actually should. Empty arrays, this is what I added it for. So it should be here instead of those parameters. Yep, right? That makes sense. And let's go to our main annotation and add the AST transformation class. Main adder AST transformation. Dot class Java. Yes, you are that stupid. Okay, test now. Let's test our main. And it works.
You need to annotate with test?
It has the test. It doesn't have the test. That's the reason it didn't run and everything works. But yeah, so I didn't try to trick you because it will work even now. So you can say I tried to trick you, but it works. Hopefully, at least. Yes. Okay. Right? Good catch. Now, any other catches, any other thoughts about this main annotation? I would say that it's pretty shitty annotation. You know why? Because it makes like tons of assumptions about the code that it will be annotated with. Give me some examples. What can go wrong? Constructors, thank you very much. I just come and assume out of the blue that this class will have empty constructor that I can call. Yeah, I mean without the parameters. That's a very naive assumption because it might happen, but it might not happen. What else? I need an answer that I can build on to continue my presentation, so please, someone.
Very complicated.
Yeah. Anyone? What can go wrong? Thank you very much, Paul. Yeah. It's good to have prepared people in the audience. If no one can help me, you always can. So the problem might be that we already may have a main method in the class. And here I'm going to show you something very funny. I'm going to write a test. This one will be test. Class shouldn't, whatever, I didn't manage in this time. Yeah, that's because of the escaping, okay. Have two public static void main methods, right? That's kind of a very strange thing to check because this is not possible. You can't write two identical methods. Even in Groovy, even Groovy won't compile. And Groovy will compile almost for almost everything, but that you cannot do. You cannot have the same methods. Now, the funny thing is that you actually can with AST transformations, because, as you saw, you can just add any method. So what I'm going to test now is this. This is a very strange code. I have my class foo with existing main class, main method. And I have a greet method which is annotated with main as well. I'm just going to run it. Guys, we have two main methods in the class. And we hid one of them, because why not? Might be another one, but that's that one. So our bytecode has two same methods. The same. So that's kind of stuff that you might encounter when you write AST transformations. And my point is, you have to be very, very defensive when you write AST transformations. You have to think about all the cases, for whatever you can, for your extent, what can go wrong. So here, at least, we need to check that we have the constructor that we call and that we don't have another main method. Well, the correct way to treat this situation will be, well, from the constructor, we just can't generate a main method without the constructor, so we will probably fail. Here, we can be like more friendly and say, okay, if the main method already exists, I will just skip generating another one. Most of the transformations that you use work that way. So if you annotate a class with toString and it already has toString, the toString won't be generated, right? It won't fail or something. But we want to do something funny, so we will actually fail on existing main method. So let's go to the main method transformation and go here and add a test. So here we are going to do main check and full screen, not that one, that one. So here I'm checking if declaring class already has main method with empty array params. I could throw an exception here, but if you ever see your compiler throwing exception on you, you will be quite surprised. You're compiling your code, boom, stack trace. Well, it happens, right? I think I even saw it once or twice. But that's not a normal compiler errors. Normal compilers errors are added in this way. Source, add error, and here you have an exception, a syntax exception, but once it's added with source add error, it will be an error. You might omit a warning here. You can say you already have main message, we won't add another one and skip the generation, and then it will be source add warning. We will fail. So the new syntax exception can add another main method, and here come the line number and the current position. So if I wouldn't lazy, I could calculate where the existing method, main method is and point it there. And then it will show me a nice arrow on this place in the source. But I'm just going to add some non-existing numbers because that's kind of, that's valid as well.
We can show you shortly. Just run that first.
Yeah, OK. I'm learning so much during the talk. I love it. OK, so yeah. Let's run this stuff again. Let's see what's going on. And it failed. The good thing, it failed as I wanted it to fail with the compilation error. And look, this is my text in the compiler phase. I can actually swear on you when I compile your code. This is so good. I love AST transformations, guys. Now, OK, what I need to fix this test is to say, yeah, we expect multiple compilation error exceptions. Yeah, OK. Let's rerun it again. Yeah, it's good. Yeah.
You can go back to your example and
Yep.
so just get rid of source dot.
Mm-hmm.
Back to the inside. No, keep the.
To keep it?
source dot.
Okay. In the I need to go to the end of the line. This is complicated.
Just 7 characters.
Yeah.
Now get rid of the source dot.
Remove source.
Hit delete.
You want it here? Yeah, okay. Okay. Yeah, I got it. Okay, this is the error that comes from the superclass.
No, keep the rest. Keep the rest. Undo. Now get rid of new syntax.
Of the new syntax exception. Got it. All right, yeah, like that.
Keep your message.
Yeah, this way.
And now, instead of the 9999s, put in the...
Oh, the node of the existing main.
Oh, yeah, yes.
Oh, that's cool. So, yeah. No, but I will. I hope it's not a problem. I'm in parade with this Mac, but I'll do my best. So it will be a declaring class get method.
You should just
Yeah, the get method will give me the node. Huh?
annotated method. You didn't answer whether you want to...
No, I want it on existing main.
We're not going to show you... Oh, we can do that. We can do that as well.
Why not?
Well, we can just tell the error where the greet is.
No, but I want to show it on an existing method. So yes, so it will be main, and I already have empty array params. I don't need to type it in. And let's try it that way.
You'll need to get rid of... It'll just say...
Yeah, bug.
Doesn't work because you're trying to get the method that you want to add.
Oh, I need the existing one. No, it's not the method that I want to add. The method that I wanted to add does not exist yet.
When you do the extended class get method, this is the one that you want to add. The one you want to report the error for is get method main with the string array parameters.
Oh, sure. Yes, of course. Yes, thank you. That will be the string array parameters, which is...
It's up there.
Yeah, it's up there. Is this. Yeah, that's the parameter. Yeah, right. Those guys actually, right? No, that's the empty array. Named arg, yeah, that's good one. Name main empty array args. That's the one I want to point at.
Yeah, just for now, just put in...
Yeah, let's put the annotated method now. Okay, that will be better. Annotated method, yeah.
Just run that.
Yeah. Your stuff is not working. Unexpected exception. Guys, my code was perfect. The toilet was on the other way of the street. And now here, look where it is. It's so close. Never mind, guys, you got the idea. I can skip the calculation of the location by asking Paul how it should be even better. No, it's not.
Because you didn't call the init method, and that's a bad practice.
What I didn't call?
At the beginning of the method visit, you should call init.
I never did it. Should I?
Yes, you should.
It works without it. With the same nodes and source?
Now you initialize source, which is what we're calling.
All right. Yeah, thank you, guys.
Now take the...
Yeah, now I need to take the compilation and see what's going on. Yeah, okay. I did it. How long it will take me to get used to this thing, I don't know. Wow, that's amazing. Yeah, here I have. It's showing the annotation. It's better than it used to be anyhow. And probably now, if I will add the existing method, main, it will work as well. Let's go. We'll have 20 minutes. No, done. We just started. Come on. OK. So, yeah, the whole thing was for that. OK, the compiler emit your messages, and that's kind of cool. Now the next, I want to talk to you the next section that we have 20 minutes for it, called AST for humans. What we are going to do is lowering the level of hell, step by step, until we have something that actually can be readable and maintainable. So we will start with the message header. I actually already had to do it because I screwed up with my live templates. So the message header AST transformation now actually does look at exactly the same way that I wanted to show you, right? I cleaned up everything, I think. Just some static imports. And on-demand static import here as well. And yeah, I think that's the clearest we can get. So it's still Java. It's still like the hardcore thing. But there is a wonderful class that called general utils. It's in the AST package, so it's not that general. It's AST general utils, which give you all the calls that I had to do, the construction of the nodes, the construction of the parameters, the construction of the array that construct the parameters, all those huge boilerplate code wraps it up in the static utility methods. That's why it's general utils. And you can static import it, and you end up with much prettier code. This code was like 2 pages long, okay? So we have here the construction. We now can directly add a method, public void, and then we construct the params in a very simple way. It will be the params that conclude from one param, string type name message, with empty array, and then statement, call on this method that called Println, and with the parameter will be the ternary, which is the annotation node in the first place, with the shout. If it's true, call on the message method to uppercase. Otherwise, just give the message. Right? Now, this is much, much simpler. Now, it's some cool device. I upgraded from the toilet to some device with handles and everything. Yeah, good, good. Yeah, so we're doing good. OK. Yeah, so that was the general utils. Use it. Whenever you need this, write the AST transformations, general utils is definitely your friend. OK, that's much better. And now we are stepping into even less hell. We are stepping into Groovy. So let's write the author-added Groovy AST transformation. We'll do it in Groovy. So the test will remain the same, of course. What we need now is create a new Groovy class. Okay. And here a G author-added class. The class will remain the same. We don't have any semicolons on the imports, which is nice, but that's not the reason we do it in Groovy. Yeah. OK, the iteration now, it's even more beautiful because it's the Groovy each. And here we have to add our field. Yeah, OK. Full screen? Yeah, OK. So this. Here we have node add field. That remains the same. But the parameter of add field is not a node with all the hell that we saw previously, but it's something that we build with AST Builder. Everyone is familiar with the builder concept in Groovy? I hope so. Yeah, I will pretend that everyone said yes. Build from spec, that's the code that we are using to build from the AST specification. And that is much less painful, because all we need to do is we are going to construct the field node, name author, all the modifiers, and then it will have constant of JBaruch, and it will be a field node, right? This is much simpler code, and it works the same. We, of course, will have to switch the implementation class in our AST transformation. So it will be author header groovy AST something. Yay. You could.
I'm sure it looks better in Groovy, don't get me wrong, but is there a reason why you could?
Yeah, it uses closures and stuff. You will end up with the same amount of boilerplate in Java by constructing closure objects. Sure you want to do it? You can do it. It will run. It's just a class.
Yeah, no, I was just figured that I saw you run it in closure, but usually the closure comes up with right? I mean, a lot of the other builders.
Yeah, but then you will be much better with the general utils.
Yeah.
Yeah, just will be simpler. Okay, this is my test. Yeah, so the test will run. I can run all the tests here to verify that we didn't break anything. Yeah, okay. And let's look at the next one. Okay, now, yeah, that's the compilation error that we should add the compilation error again. Yeah. Expected multiple, what it was? Multiple compilation errors exception. Yeah, okay. Now it should be good. And, okay. So that was, well, there are actually 3 ways to run Groovy transformations, to run AST transformations, to write AST transformations with Groovy. It's the AST builder. It's the, what else do we have? Run, construct from source, and construct from code, right? From string and from spec. Yeah. So there are other helpers that can help you build AST transformations with Groovy. But since we don't have much time, we only have 15 minutes, I want to show you the real, like, new and interesting stuff. So 3 additional features that I'm going to use to show you are all written by a very nice guy called Sergei Yegorov. He's an Estonian guy that works for some startup that use Groovy a lot. And he was hooked by AST transformations. This is very addictive stuff. Once you start writing AST transformations, you like do everything. You eat breakfast in AST transformations. You do everything in AST transformations. This is very addictive. So he was like hooked, and but he was hooked in a good way. Not only he wrote ton of AST transformations by himself, he also added new ways to write AST transformations. So his handle in Twitter and in GitHub is bside up. Bside up? Bside up, yeah. Bside up. And if you happen to see him or something, definitely deserves some kudos for what he does. So what I'm going to do now is to rerun our message header Groovy AST transformation, the heavy one with the ternary operator and everything, in Groovy using the macro extensions. So what we are going to do is create a Groovy class. And yeah, he was in the Greek conference. Yeah, so it will be what was it? Messenger, Nahon class. Okay. Yeah. So here we go. This is the same class, and here is the header methods. What happened? That's this one, right? Yeah. That was weird. Okay. So here we go. Same AST node. We still get it for the shout. We still need it, the value of the shout. And we still need the node number 1 as the class, so we will add message on it. So we add the message, it will be still public void, the params still be the message string. It will throw no exceptions. And then look at the magic. I use an extension method called macro. I just added my, let me show you my Gradle script. Yeah. Here. So I have 3 dependencies. Groovy and 2 dependencies of Igor. One of them we'll get it in a minute, the macro method. Now we are looking at the macro Groovy. So I added this dependency, the macro Groovy, and it registered an extension method, which means that I can use now methods as they were for each and every class that applies. So this is what I'm doing now. I'm using the macro method. And macro method, it has some Boolean, which means whether I want an expression or a statement. It's not a very good choice to make it Boolean, but whatever. And then it has a closure. In this closure, I actually write Groovy code, valid Groovy code that will be changed to the AST transformation code in the compile time. So here, I just use Println, and here I need to escape this member a little bit, so it will differentiate between the code here and the code in the outside world, in the outside transformation. So I escape it with $V. And then I continue with valid Groovy code. So if the member, this guy, the shout, true or false, message to uppercase, or directly message, right? So I still have some decorations of this STL, but the core content of my method is pure Groovy. And in order to fix that, I need to go to my messenger. It was messenger, right? And replace message Groovy, a message header Groovy transformation. OK, now the test will work. So that was even less hell and even more groovy. And here we are getting to the next logical step on top of this macro method, this macro stuff. What if I will write this message, this code of Groovy, not inside a visit method of my AST transformation, but in a regular method that then I will mix in during using the extension mechanism into an AST transformation class. So what we try to do is take this code, put it aside, and then in compilation time, add it by using the extension method mechanism into an AST class. And that's what the other project of Igor does. So that's the other guy, the Groovy macro methods project. So that's, again, a bunch of extension methods that I need to run. So in order to use that, what I need to do is writing a new class. This class will be safe header macro method extension. I will use a new example. This example is what the safe operator does. When we have this dot and question mark that will allow us to return null instead of failing on null pointer exception, we will do it with the method. So we will add a method that calls safe that I can call and then not get the null pointer exception. So here we'll start with the test. Where is my test? Here. I think I have a test for it. Test void shouldn't get NPE when using safe. OK, and here let's see if I have it. Oh, yeah, Safe. Yeah, okay. So here is my script. That wasn't right. That was good. Groovy. Okay, here is it. So I have a definitely null object. I can promise you it's null. Assert safe, calling to safe. On the object hash code, this will throw null pointer exception. It will throw null pointer exception without using safe, but now we will add this safe method that will save us from null pointer exception. So in Groovy, we are going to write new Groovy class, and no, that's not it. Safe adder macro extension. Yeah. Safe. That's the test. Safe. Where is it? It's only test. Why is that? Ah, because I don't need anything. I can just go and do it here. Where is my safe? Well, okay, so yeah. Looks like I don't have it. Again. That's a shame. It's really a shame because here you cannot help me, guys. Yeah, let's try to find it. Ah, okay, it's actually Java. That's the reason I didn't find anything. Okay, I will just show you the. Yeah, okay, so here it is. So what I have here is a method. This is not an AST transformation class. It not extends from AST transformation. It doesn't have any annotation stuff. It's just a regular class which have a method with annotated with @macro. And here I just write normal Groovy code, which returns, this is the normal AST transformation code, which returns an expression that I want to be mixed in to whatever place I want to mix it in. And this should be registered as an extension class. So for here, I will go and add a new extension module. This is the regular extension stuff. Meta-inf services, new file, that's the name, and safe agent module, right? Nothing fancy here, just registering my class as an extension, and then the test should pass. Yeah. Okay. And now I have 2 minutes, and that's perfect to show the last but not least feature of Igor. Writing it in Groovy, it's very running AST transformation in Groovy, it's a very powerful thing to do. But again, and looks like I'm wrong here, and you correct me if I am, it has some penalty, it has some performance penalties. Writing AST transformations in Groovy. Yeah, only if I don't use compile static. Well, that's I didn't know, but still I will show it anyhow because it's cool. So assuming you do have a penalty when running in Groovy and you still want to run your AST transformations in Java, you can use something new, which is static Stl Generator. You remember that code? And you remember how Java code, how much Java code I needed to run in order to get this transformation? All I need to do now is going to this web service, web console, clicking on Show AST, go to Generator View, and enjoying this very readable, very concise code of whatever I like. So those two, I'm not very interested because the message I'm getting from, I know how to get that. I get it from the method, and the shout is coming from the annotation. But all this part is exactly what I need to copy-paste in my Java AST transformation class. And it will just work. That's all. Thank you very much. The toilet is still inside the room. I hope you enjoyed it. Well, we ran out of time, but if you still have any questions, I will be around. So, thank you.